I see we two people on the chat this morning, but that's fine. I think let's start, and as people join, they can join, and the recordings will be available again, hopefully later today. So today basically want to focus on study unit 8 and hopefully study unit 9 as well. But before that, there has been on the chat a lot of questions around when to use which table, so which Z table. So basically, I just quickly want to do a summary on that again, and then we can go into the next set of study units. So basically, the question was when to use the negative table or when to use the positive table. And for me, this is normally, when I look at it, you would see that the negative table, if that is the 0.5, the negative table will have it colored in the smaller region normally. Then the positive table, if that is the 0. Okay, sorry, let's get back to the screen sharing. Wonder why that didn't happen. Can you see the screen now? Okay, cool. Okay, so basically, we always need to decide when we get a question, do we use the negative table with a negative graph? Do we use the positive table? So how I always look at it is the negative table has the smaller part that is highlighted. So the data within this table. So whatever the values is within so we'll always refer to that part. In the positive table, when that is again 0, the positive table would normally have that whole section highlighted, and you will see the positive table is always bigger than 0.5. The negative table is always smaller than 0.5. So again, if you have then the probabilities that are in the table below the graph, so that probability then will be showing that bigger area. So in the exam, when you get a question, and how I normally look at it is, so if that will always be your 0, so say I needed to get where Z is bigger than 1. So say Z was bigger than 1, then I need this area. So what you can use is the table that you're most comfortable with. Remember, it is online, so you have all the tables in front of you. So if I needed to get that area, I would go to the positive table. The positive table's value will give me that bigger area. So it will give me that area. But remember, I need the green area, so I would need to say 1 minus whatever the green areas. Sorry, I need to get to the green, so I need to say 1 minus whatever the purple area was, and that will give you the green area. Okay, so if I need to basically get that green area, I would use the positive table. I would say 1 minus the purple area, because that purple area was covered within the table, and that will give me the green area. If I needed to get z smaller than 1, then it's a perfect match. So whatever is in your table will be the numbers that you are looking for. Okay, now let's look at if something was negative. So if I had, and let's say that is z smaller than negative 1. So if it is smaller than negative 1, I want that area. So then whatever is in this table is exactly, so whatever is in the negative table is exactly what I'm looking for. So then again, just read off the table. If I needed to get z is bigger than minus 1, then what I would do again is say, okay, z bigger than minus 1, so I are looking for this area. That is not giving it to me, but at least I know a part of it is. So then I would again say 1 minus the yellow area, and that will give me the blue area. So basically, one just basically always need to check which, if it's positive, you just need to check if it's bigger than or smaller than. Then you need to know, okay, I use the probability that's in the table, or I need to say 1 minus the probability of that table. If I look at the negative, exactly the same. If I need to find the smaller area, I just read it from a table. If I need to find the bigger area, again, I say 1 minus the bigger area. Okay, so I hope that is a bit more clearer. So after the guys have watched it today, just on the chat, let me know again, and we can again go through it if needed. Okay, so the rest of the session today is on study unit 8, and hopefully we'll get to study unit 9 as well. So study unit 8 is a lot to do about confidence intervals, and I think what we need to know and remember about the confidence intervals, and I think it was in the message that the lecturer also sent through, is remember that, and I'm nearly going to write it here, so let's include quickly a new slide. So basically, remember there is a Z and the T for confidence that we will use for confidence intervals. The Z is where the standard deviation is known, or when we work with proportions. I hope I'm spelling it correct. The T is when so the standard deviation is known here, and that is, and let's just add the population. So basically, with the T, it is when this population standard deviation is basically unknown. Then we will use the T. So confidence intervals is basically between three things. So if I tell you that the population standard deviation is known, or I don't need to say it is known, they just tell you that the population standard deviation is equal to something. Then we know we can use the Z. What they will sometimes say is the sample standard deviation is, so then we need to go to the T, or they can say, we'll check now if there's another way that we're using it. Proportions is always a Z. So that is just the rule. So there's no T's for proportion, it's always the Z. The other thing with confidence intervals is it's always two tails because it's a lower confidence and the upper confidence. So the one tail, two tail only comes in when we're looking at hypothesis testing. So confidence intervals, we don't need to worry about that at all. Okay, so let's go into the first question. So a statistics practitioner took a random sample of 50 observations from a population with standard deviation of 25. Okay, standard deviation is known, so we're working with a Z. And a mean of 100, a 95 confidence interval of a population mean. Okay, 95 confidence interval for the Z is always equal to 1.96. Okay, that is a given. I've written it in my nearly my study unit 8 summary as well. It's always, when you see 95 confidence interval for the Z, always equal to 1.96. So basically we are working here with x plus minus Z times that. So let's see, a statistic took a random sample of 50 observations. So we know that 50 is your N from population with standard deviation of 25. So we know that the standard deviation is 25. We know that Z is 1.96 and a sample mean of 100. Okay. Okay, so that is, so the first thing that I always look at is to see which ones I can cancel and which ones not. So if I need to start adding, so 100 will be somewhere in the middle. Then there will be a number lower than that because I'm subtracting, and there will be a number higher than that. So a lower confidence level of 100 will not work. So that is out of the question. Upper confidence level of 10 will not work because you need to have it bigger than 100. So I'll take that out. Those two are between 100, those two between 100, between 100. Sure, that looks, you can't, because 100 needs to be in the middle. So if 100 is in the middle, that side I nearly took off 60, that side I only added 6. So it can't be that one. Okay, 100 will be exactly in the middle as I'm subtracting something on this side, but I'm adding the same value on that side. So 100 will be exactly in the middle. So that one can't be. So we're sitting with 2 that we actually can be the answer for this one. Okay, so there's no short way further on, so we need to use the calculator. So it is the, so basically 25 divided by the square root of 50 times 1.96. So what is very interesting, and you guys can just sometimes check in the options, this option that I deleted or add as a no-go. So that was the 100 of the x, and strangely enough, this part is the part that I will add and subtract on both sides. Okay, so then basically it's 100 minus that, which gives me 93.07 for the smaller one. So that already I can see is that. And then if I add that 6.9 to the 100, gives me 106.93. Okay, so basically we got it that option 1 was the correct answer. But again, you would see that with this, I nearly already could ignore 3 of the questions. So can we go on to the next one, so that we can just nearly get into the rhythm of this, and then I'll take a few questions after 2 or 3 of these. So that was a way that they could ask it, with giving you nearly all of the information in words. Here what they did was, so they said, from information below, determine 95 confidence interval. Okay, they give you the x, they give you the n, they give you the standard deviation. But remember, population standard deviation is that. So what they've given us here is the sample standard deviation. So when we have sample standard deviation, we automatically go to T. Okay, so I think that is important in this question, so that you know nearly the symbols also for what is a sample standard deviation and what's a population standard deviation. That we did way back nearly in study unit 1 when we started explaining all of this. So we need to actually get a t-value. Okay, so t-value, how we do that is, let's just quickly admit that. So t-value, how we do that is we get the degrees of freedom, and then because it's two-tail, it will be the alpha divided by 2. And just to reiterate, because we're working with confidence interval, it is always two-tail. Okay, so it's always two-tail for confidence interval. So we will need to go to the t-table where it is degrees of freedom is 99 and where the alpha was 0.05 divided by 2. Okay, so that was 0.025 and 99. So you would again on the table have that you go down with degrees of freedom to 99, then across where alpha is equal to 0.025. And where we cross those two, we will get the value. So I just quickly wanted to go to my tables and I'll show it to you. And you must just let me know when I put it on the second screen if you can see it. Okay. Can you guys see it on the second screen? The degrees of freedom that I have with. So just give me a thumbs up if you can see it.
Yes, I can see it.
Okay, great. Okay, so basically we've have that degrees of freedom is 99. So we go all the way down to 99. Okay. Let me quickly see if I can highlight that. Come on. Let's say. And then we go across where it is 0.025. Okay, so let's go then to
Ja, det söndervis på sån
Hello, can you still hear me?
Yes, I can hear you now.
Okay, I'm now on my cell phone. I'm just trying to reconnect. I was dropped off the Wi-Fi, so I'm just trying to reconnect that I can go on with showing you anything because you probably can't see anything at the moment.
Mm.
Okay, let me see what happened here. Okay, so while I'm trying to reconnect, I think there was now a question about how did I get to 99 for the degrees of freedom. So the 99, how you get it is the formula is n minus 1. So whatever your sample is, you needed to minus 1 from it. So the sample was 100. So 100 minus 1 will give you the 99. So that is your degrees of freedom for your T. Okay, why is it only team set? Oh no. Okay, let me. Still can't get in. Okay, this is very weird. I'm just going to restart on my side and see if then things will work again. So just give me a few minutes. Technology. So I'm wondering if the recording is still going. I'm hoping it is, and then, but we'll see. See, I'm just quickly restarting, and then hopefully I will be back online. Okay, so while I'm now waiting, was there questions around the first one that we did and the one we're now doing with the T? Okay, I am back. Okay, guys. It seems like it. I don't know if it's still a telecom issue. I am actually now working through my hotspot. So you guys can you guys hear me?
Yes, I can hear you.
Okay, cool. Let me. Yeah. Technology. So let's quickly, and you can still see the screen.
Yep, you can see now.
Okay, cool. And let me just, I want to, it will go on and off, so don't worry about that. Just want to, and you're supposed to see some of the tables now. Okay. So hopefully we're back with that you can see the 99, the 0,025, and where it crosses we get the value of 1.9842.
Mm-hmm.
Okay, so again I think, yeah, so how you calculate the degrees of freedom is n minus 1 for your t. So n was 100 minus 1 will give you the 99. Okay, so then when we go back into this formula, we then just write it as we normally would have. So it's x plus minus the t value now, which is 1.9842, and that multiplied by the standard deviation, which is 5, over the square root of 100. Let me quickly. So over the square root of 100, and square root of 100 is basically 10. Okay, so it will be 200 plus minus whatever is in there. So let 2 times 5 divided by 10. So I got that it is 0.9921. So if I add it, it will be 200.992. If I subtract it, it will be 199.008. So option 3. But we haven't now even looked at the others. So again, what I would have done before I've even started with this whole calculation is 200 is in the middle. So if 200 is in, my upper must be bigger than 200 and my lower must be smaller than 200. So that one is out because my upper is 20. So sorry guys, if I drop off again, I think let's just see how it goes for the rest of the session because of the problems with the networks on my side. Okay, so if we look at this option, the one is just bigger than 200, The other one is much smaller than 200. And 200 will be in the middle. So that can also not be an option. Here they've actually given us the 200 and the part that we're going to add or subtract. But again, 200 in the middle. So you need to have the smaller one will be smaller than 200. The bigger one will be bigger than 200. So this one will also not work. 200 needs to be in the middle. So here we add 9 that we added on the one side and only 2 subtracted on the other side. So option 5 actually. So we could have nearly get to the answer without nearly needing to work out the answer, because all the other ones was not at all possibilities. Okay, so that is a way to calculate or to work out also if you didn't go through the whole process. Okay, let's look at the next one, and let's look at what information they do give us. So here they tell us that a random sample of 25 was drawn, and let's make it a bit bigger. A random sample of 25 was drawn from a normal distribution, population standard deviation of 5. So we go to the Z. The sample mean is 80, 95 confidence interval, so we know that Z is going to be 1.96. Okay, so when we then write up the formula, let's just do that, and then we can start eliminating again before we even get to working it out. So 80 will be in the middle, so that can be a possibility. 80 in the middle, that can be a possibility. 80 in the middle, that can't be. 80 in the middle, that can be a possibility. 80 in the middle, but this is, so if I look at that one, and if I look at that one, the one is just multiplied by, what was it, 100? So that can't be. So even before I'm looking at answers, I'm thinking that is probably the one that it's going to be. But there are 3 options for you. So let's work it out. The standard deviation was 5. The n was 25, so square root of 25 is 5. So 5 divided by 5 will be 1. 1 multiplied by that will be 1.96. So my confidence intervals will be 80 minus 1.96 for the lower one, and 80 plus 1.96 for the top one. So the lower one is 80.04, and then the top one is 81.96. Okay, so that gives me option 1. So I think the most important with this one is that we basically, you identify if you're going to use a Z or T. That was easy to identify in this one, and then you follow the process with how to work out the confidence interval. So first identify, then I think the other important one is when you see that we're working with a Z and the confidence interval is 95, it is always 1.96. Okay, so let's look at the next one. And let's make it a bit bigger again. So here they talk about a simple random sample of 30 was collected from a population for which it is known that the population standard deviation is. Okay, so it is known, so we're working with a Z. 95% confidence interval, so we're working with a Z that is 1,96. The sample mean has been calculated as 240. Okay, so we know then that 240 will be in the middle. We're working with 1,96. At the top, it was 10 because that's your standard deviation. At the bottom, it was 30. Okay, so let's look at options before we. So that one and that one is very that and that is very close. If I just look at that, this feels to me like that was for 240, and that is nearly the part that we're going to work out there, but this is wrong in any case. Then I see here they have the top one, so the upper confidence first, then the lower confidence. So it seems like those two are just, so there's a lot of numbers here that we need to be very careful when we're working it out, because they have scrambled just a few of these numbers. Okay, so there's no shortcut in this one. We need to say 30 divided, or 10 divided by the square root of 30, which is 1,8259 times 1,96, which gives me the 3.5785. So my confidence intervals will be 240 minus 3.5785, and will be the top one will be the 340 plus. So let's quickly see with 240 plus, sorry. So the bottom one is 236.4215. Sure. Okay, 236.4215. Okay, so let's just check the top one. Is 243.5785. Okay, so that is option one. So basically, again, what we did is we identified that we're working with a population that is known. We've identified then that if it's known, it is the Z. Very seldom, but and let me, so there's normally three possibilities for the confidence interval that they will use in the exam: a 90%, a 95%, or 99%. 95 is nearly the most used, but if we have, and you can write this down, but it's also in that page that I did the summary of a confidence interval. When it is a 90% confidence interval, so let me also, so when it is 90% confidence interval, we're working with a Z of 1,645. When it is 95%, we work with a Z that is 1,96. And then when we work with 99%, we work with a Z that is equal to 2,58. So that are the three ones that they use mostly 95, but they can ask for 90 or the 99. They won't ask a 91% or 92. It's basically between those three that they normally ask, and it is most of the time the 95%. But this is nearly the three ones that you can remember. It that is how it will be. So you don't need to worry that you now suddenly get a 98 or anything like that. That will not happen. Okay, so talking about a different one. Okay, there we sit with 90, but let's first see what other information they give us before we jump to 1,645. Okay, random sample of 40 men on an average 20 cups. So I just do that already with a sample standard deviation of, okay, so sample standard deviation T. Okay, so now a random sample of 40 men. So then to get the degrees of freedom, it is 40 minus 1, which will give you 59. The alpha was, we're working with 90%, so the alpha is 10. So in the table that we will look for, it will be 10 divided by 2, so it will be 0.05. Okay, but let's first just read what we need to. A random sample of 40, blah, 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 with that, a lower confidence. So we need to basically just find the lower confidence. Okay, it will be less than 20. That is probably an upper. So we have eliminated two of them, and it can only be one of the options 3, 4, or 5. Okay, so let's go back to my table. So degrees of freedom of 39. And we worked with a confidence of 0.05 because it was the 0.1 divided by 2. And then if we go down to 95, that is basically, so we have this, the T as 1,6849. So then when we go to this, it is 1,6849. And you will, so let's just first do this finish. So random sample with an average of 20 cups. So we know that the sample was 40 and the standard deviation was 6. What you will notice is that for a 90%, if we used the Z, it was 1,645. So it's not that far off the T. And the bigger the T, the closer it becomes the normal distribution. So let me just show that for you as well. So remember, and hopefully you can still see the table, but when we set for the Z, the T over Z would have been 1,645. So look how closer we get to 1,645 when the bigger we get. And here you can see nearly when it starts getting bigger than 120, we're actually very close to the normal distribution. Here you can see we're getting the 1,96, the 2,58, the 1,645. Bigger your sample, the closer it gets to the normal distribution. And that's why it's sometimes, if you use a sample of 100 and it is a T that you need to use, that's why it's sometimes very close to one of the other options, just because it is so close. How did I get the 10? Okay, so the 10 was, they tell me the 90%, so 1 minus 90%, because I need to get to the alpha, will give me the 10%. And because we're working then with confidence intervals that are two-tailed, we need to divide it by 2 to get to that one. And remember, confidence intervals always two-tail. Okay, so now this one I need to work out with my calculator. There's nothing that makes it nice to Okay, so when I divide that by that, I get 0,9487. Sure, I hope this is right. Times 1.6849. So I get it as 20 plus minus 1,5984. We'll just see if that is actually, and then we only work with the lower confidence, so that plus 20, I don't even get one of the numbers, so let me just quickly see. Random sample of 40 men, average final examination standard deviation equal to 6. Okay, so let me just work that out again. Okay, I don't get any of the numbers. Why do I don't? Let me just quickly see. 39, 0,05. Just want to see that divided by that is, yeah. So I just want to see again, 0,05, 1.6849. .6849. The 6 was right. That is right. I don't get the same any of these answers. So let me quickly, that's weird. I just want to see what, if there's maybe a mistake in the answer set, or if I've now missed something here, I've calculated something wrong. Let me just quickly check. Okay, so there's a mistake on the getting in the study guide. Why are they using? Okay, so there's a mistake in this in the study guide. So in that example questions, because yes, everything is according to what they've done, but they get for the degrees of freedom also 39, but they get 1.683. So they used 41 instead of 39. So there's a mistake in the study guide. Okay, so so this is correct, but then there's actually not a answer for this as one of the options. Okay, so unfortunately, again, so if you look at question 9 on page 174 of the extra question sets or the extra examples, there's a mistake in that document because the degrees of freedom, the 39 that they reference to the table is wrong. Okay, so it's not me that are going mad at this point. It is a mistake in the tables. Yes, quick. It's a question. Okay, so there's still 2 on this. Okay, cool. No worries. And just want to make sure, can you guys still hear me perfectly? Just want to make sure that we are still connected well. Okay, so let's quickly look at the next one. A random sample of 80 observations results in 50 successes. Okay, so here we're working with the proportions. Okay, but proportion is also always Z, 95 confidence. So at least we know we're working with a Z that is equal to 1,96. Then we need to look at the formula for confidence interval for proportion. Please don't remember this as it is in the formulas and you can get it from the page that I also created. So don't worry about that. We just need to know how to use it. Okay, so Z is equal to 1,96. A random sample of 80 observation results in 50 successes. So P will be 50 divided by 80. So let's just get that. What is 50 divided by 80 is 0,625, so that I know what to use here, 0,625. I won't be surprised if 0,625 is not even mentioned. So it is mentioned in one of the options. And that might be the answer to this whole thing. But let's first work it out. 0,375, and we divide that by n, which is 80, and we need to take the square root of that, so a lot of into this. Okay, so it was actually 0,625 plus minus 0,1061. So if I calculated that whole thing, it was actually the 0, okay. They say 60. That's not going to make a big difference at the end. So let's just quickly go through some of the reasoning again. That needs to be in the middle. So I can't have a number that's bigger or that sits at the upper level that is smaller than that. So option 5 can't be. Okay, that sits in the middle, so it can be this one, can be this one, can be this one. But basically, option 1 and option 5 we have eliminated already out of the options. Okay, so basically 0,625 minus 0.1061 gives us 0,5189. Okay, so they want rounded off to 3, so let me just do that already. So, 0,519. So that will be the correct one. But let's just get the top part as well, just to make 100% sure. 0,731. Okay, so that was basically option 4. Okay, so we identified it as a proportion. Then we know it's a Z. Z of 1,96 is always, 95% confidence interval. The Z is always 1,96. Okay, so let's look at the last one for confidence intervals. And before population proportion, so we're going to work with the proportions. So that we know is a Z. So again, if we work with proportions, I know I automatically work with a Z. 95% confidence interval, I know already we're going to work with a 1,96. So let's look. According to a surprising number of results consistent with the Stats SA report showed 46 out of 200. So my P will be 46 out of 200. So let's just see what 46 divided by 200 is 0,23. Okay, so 0,23 plus minus 1,96 with that whole area. So again, let's just go through options first before we even work it out. So 0,23 will be in the middle. So the upper limit must be higher. So here we see the upper limit is lower the lower limit is higher, so option 2 is not an answer. Okay, upper limit must be higher. That is not higher than 0.23. That is not an answer. Interesting, that and that and that match, so I would nearly automatically want to say option 1 is the answer, but let's look at this one. So this can also be because 0.23 is in the middle, 0.23 is in the middle. This one again can't be because there's the lower limit needs to be less than. So we basically have option 1 or option 5 that we can nearly be one of the options to work with. So again, we need to work with the formula of P. I just want to write it down again because this is the other one I remember, but this one is always for me so the likely answer of that is probably going to be the 0.2884. I'm just nearly, so it seems like in all of these questions they give you the x and they give you the part that you need to plus and minus. So let's just check. So it's 0.23 times 1 minus 0.23 is 0.77, and that divided by n, which is your 200, and the square root of that. So 0.23 times 0.77 gives me 0.177 divided by 200 gives me 0.000886. If I take the square root of that, I get 0.0298. If I multiply that by 1.96, I get okay, wait, 0.0583. Okay, so that was not the one that I was actually looking for. So this time I didn't do that. Okay, so 0.23 plus minus 0.0583. So first we'll do the bottom part. So that minus that will give me 0.1716. That plus that will give me the 0.2884. Okay, so which is option 1. Okay, so that is confidence intervals. So basically, we started off by saying with confidence intervals, you nearly need to know that you will use the Z when the population standard deviation is known, or you will use the Z when you have proportions. If it is a population standard deviation that is unknown, we will use the T. And then with the T, we need to know how to basically work out the degrees of freedom. The degrees of freedom is n minus 1. Then whatever confidence interval or confidence percentage they give you, you need to say 1 minus that. And because we're working with a confidence interval, it is always a two-tail. So that means that we will need to divide that 1 minus the confidence number that you got divided by 2. So if it was a 90%, we need to say 1 minus 90%, that will give us 10%, but 10% divided by 2 will give us 5%, so the 0.05. Okay, so that's just a quick recap of nearly what we need to remember. With the Zs, we normally get that they ask us for confidence interval for 95%. 95% is always a Z equal to 1,96. Okay, so this is basically the end of study unit 8. Just again a recap, we also did look a bit on how to use the tables for the Z. So again, just go back to the earlier part of the recording to get to that. Okay. Quickly, everybody okay with study unit 8? Then we can just start a bit on study unit 9, and then in the next session we'll basically finish with that as well. So everybody happy with study unit 8? Is there any questions? Just a thumbs up if we can continue with the next study unit. Okay, cool. Okay, awesome. Okay, so let's close that. Let's go into the next study unit 9, and this is the hypothesis testing. So the important thing here is with hypothesis testing, and let me get so with hypothesis testing, we will have something like sorry. Okay. So to determine the one tail or two tail, you will need to look at the alternative distribution or the alternative hypothesis. So the alternative hypothesis will determine if you're working with a one tail or a two tail. If the only time it is two tail is when this is not equal to, because not equal to means it can be bigger or it can be smaller. So when it's not equal to, it's a two tail. For all the others, it will be a one tail. So you will get that the one tail can be smaller than, it can be bigger or equal to, it can be set as that. So, and that will then be the ones that are one tail. So it's nearly easier to identify the one tail, because if it's not equal to or not equal to, then it is a one tail. So when we see that sign, it's two tails. When we don't see that, it's a one tail. And I think that is nearly how I always look at it. So there's what, 1, 2, 3, 4, 5, 6, 7. So there's 7 questions in here. So I first want to just run through all 7 and identify if it's one tail or two tail. Okay, so not equal two-tail. Okay, so then that should have not been a toe-tailed. Okay, so it will be in this instance a two-tail and not a toe-tailed. Then we look at the next one, bigger than, so it's one tail. Okay, so let's look at one tail. Okay. Not equal and not equal, so it's two tail. Okay, so in everyone, okay, so here it's something different, so we will come back to that. They are something different, but look at that, so it's one tail. Okay, we'll get to this because we don't know yet. So let's look at this one. Hypothesis testing, where you can see bigger. Bigger is one tail. Okay. So even if there's not the other information. So I just quickly wanted to nearly show you that is how in the exam you can also nearly do it, is to say, let's first look at the sign of an alternative, and that will determine for me if I'm working with a one tail or a two tail. Now I think that is nearly, again, how I like to run through these stuff. Is I just quickly wanted to show you in all of them that we had something like that. That is how we do it. For interest's sake, let's look at this before we look at the other ones. I like the definition ones. So hypothesis testing, you would have seen what I did. So I said, so without even looking at something, I said my one will be, there will be something and there will be something. That one is always the equal, and this one will be dependent on that not equal to. So just with that in mind, x, that will never be. So it's always the mean that is written like that. So the null hypothesis is always the equal. Okay, so that one and that one is no go. So again, nearly by using what the theory is, I automatically, a 5 can't be. Option 1 and option 3 can't be. Okay, so a professor of statistics refuses the claim that the average student spends 3 hours studying. So he basically says that he doesn't believe a student spend that amount. So he doesn't say more than or less. He just says it is not equal to 3. Not equal to 3, and there we have the right one. So that will also be wrong, and 2 would have been the right one. So he didn't say in his claim that students spend more than 3 hours. He didn't say that they spend less than 3 hours. He just said that they're not spending 3 hours. So with that, basically then we know that it is not equal to 3. Okay, so again, it's nearly in some of our understanding of the words as well. Okay, here we need to work out a bit more. So let's go back to the first question and let's see if we can do one or two. So looking at this, they're asking us, so now we nearly, with all of the rest of the questions, you will see that they ask you to work out sometimes the standard error. They will look at the test statistic that you will need to work out. You need to work out the critical value, and then they would ask you to nearly say if you're going to accept or reject. So look at this one in the second one. Okay, there's the critical value, there's the test statistic. Okay, they brought in a p-value, but also then do you reject or not? The same here, critical value, the t statistic, the p-value, reject or not. Here they ask us straight for the p-value. Here again, ask us if that is correct. Ask us if to work out the test statistic, critical value, p-value, make a conclusion. And here they're basically asking us a lot on to nearly calculate if we make the right conclusions. So for hypothesis testing, that is nearly the way you would do it. So when I look at hypothesis testing and I look at these questions, the ones that are for me always the easiest, I would do first, nearly to see if there's not something that I can nearly eliminate. So let's look at this one. What do they give us? They give us that, so we know that we are working with a Z value at least. So we will first need to work out the Z value. So remember, how do we calculate the Z value? So that is now basically taking you back to study unit 7. So we needed to know study unit 7. So the formula is to get to the Z. So it is 980 minus 1,000. Sure, so that will be a negative number. So so this is what we're working out at the moment. Divided by 200 over square root of n. N is 100, so the square root of n is 10. So basically minus 20 over 20. That is also your standard error. I think that we did in the previous session last week. So standard error is 20. It's also correct. See, so in the process, we're nearly answering all of the other questions. So minus 20 divided by 20 is minus 1. Okay, so this one is the wrong one because we actually want minus 1 and not minus 0.1. Let's just look at the other one as well. So there we set with 0.01. So your confidence interval, or the value that we would have gotten there, to get to the 100, so we're actually working with 99%. So I'm not even going to go to the table. For me, I remember that when I'm working with a Z, working with two-tail, 99 was equal to 2,58. Okay, so your critical value is 2,58. That is correct. So then, just to look at if we accept or not. So my Z is -1. My T or critical value is 2.58. So reject H null when p-value is less. So we don't have the p-value. We're not going to calculate it. But basically, what we could have done, because it is a two-tail, we could have just written that part in there as well, just to look at it. So this tells me that the value that I worked out falls within my acceptance. So we will reject when the p-value is less than that, but the p-value is not going to be less than that, because you can see it falls in the acceptance value. So that is more a definition than referring to what we actually have in the table. So remember, when the p-value is sitting in this area, the p-value that we would have calculated with a -1 would have been, sure, I don't know. I need to go to the table, but that value at the moment here is bigger. That's why we not reject. But if it was smaller, so if it was that area instead of the area of the, then we would have rejected it. So that is just more a definition than anything else in this instance. Okay, so that was the first one of hypothesis testing. But for me, it is nearly, you identify if it's one or two tail. With that, then because I work with that, I know that I'm working with a Z. Then I can work out my T-stat. So the T-stat should have been -1 instead of that. While I worked this out, I actually did work out the standard error as well, because that is the standard error. And we did that a week or two ago. The critical value, I can basically read off the table. Yeah, so that is the first one. I think I'm going to stop here now, and then next time I'll just schedule for us sometime in the week as well. So probably I'm going to schedule for us time on Wednesday. So let me just, and then another time as well. So probably Wednesday, Friday, and then Saturday again, so that we can get through Wednesday through study unit 9, and hopefully study unit 10, and then the last two sessions, the 13th and next week Saturday, that we can do the exam prep. So basically, on Wednesday, I want to finish with study unit 9, finish with study unit 10, finish with study unit 11, and then on Friday and Saturday that we do the mock exam and go through that for you. Okay, So sorry for all the connection problems. I think a few other people had that as well. So thank you, Telkom, for that. Just some bad publicity now for them on this, but yeah, thanks Telkom for that. But I'll share the recording that Rian makes it available to everybody again during the day. Any other questions before we end the session? Or fine on your side?
Thank you.
Okay, cool. Then guys, I'll schedule for us sometime next week again, but it will be, let me quickly admit Precious as well, but then Precious, while I'm adding you, I'm just gonna quickly, we are nearly finished now, so just to let you guys know, the 11th I'll schedule for us a session as well. So for the 11th, I'll schedule a session. For Friday, I'll schedule a session, and for next week, Saturday as well, because you guys are writing on the Monday. So on Wednesday, I want us to complete the study units. So if it runs over time, it's fine. We complete the study units so that on Friday and Saturday we can focus on the mock exam and finish that for you. Okay. So have a good Saturday and weekend, and we'll start following up on the rest of the discussions on the chat. Okay, thanks guys, and have a